Please Look Up is recorded in the Scitech Planetarium on Whadjuk Noongar land. Good evening, everybody, and welcome to Please Look Up, the monthly podcast produced by Particle, where we take you through a guided tour of the night sky as seen from Perth, as well as taking a deep dive into some of the more out-of-this-world space news. In this episode, we'll be discussing what you can see in the night sky in the month of July, as well as taking a deep dive into the Euclid spacecraft mission. My name is Leon, and I'm joined by Sharna, a professional presenter from the Scitech Planetarium. Sharna, thanks for being here.
Thanks for having me, Leon.
Now, we'll start this like we always do and ask what's up in the sky this month. In particular, if I'm out looking at the sky, what sort of planets can I see in the night sky this month?
Yeah, so in July, we still get a really good view of Venus up in the west. So just after sunset, the brightest object that you'll see in the night sky will be Venus.
It's been there for months.
Yes, it sure has. But Venus will soon be passing behind the sun. So this is probably the last time to get a really good view of Venus. So I'd definitely pop out if you get a chance.
Okay.
Yeah, so we've got Venus up at the moment, but we also have Mars up there in the west. But it's not as easy to see as Venus, but it's still up there in the very early evening if you do get a chance to have a quick look.
Okay, so Venus is just going to dominate the western sky, is that right?
Sure is, yeah, definitely.
And Mars is just not really trying that hard.
It's there, but yeah, definitely not trying as hard. So Mercury will appear in the second half of the month, just next to Venus after sunset, so that's worth keeping an eye out for as well. I'd maybe pop in your calendars the 28th of July. This is a good day to get the best view of all three.
Oh, all three, Venus, Mercury and Mars.
Yes, yeah, absolutely.
Okay, all right, so is Mercury going to be as bright as Venus?
No, Venus will always kind of dominate that sky, especially towards the end of this month.
Okay, but if I'm out like a few nights in a row, I should be able to see Mercury just kind of appearing and then moving across the sky as well?
Yeah.
Fantastic. So that's Mercury, Venus and Mars, the rocky planets. That's convenient that they're all kind of in a nice straight line there. What about the gas giants? Can I see Jupiter or Saturn or anything like that?
Yeah, so later in the evening, Saturn rises, so at about 9 p.m, and Jupiter will pop up at around 2 a.m. But the best time to see these two planets is just before dawn if you happen to be up and about at that time.
Okay, yeah, I see what you mean. You either need to be up really late or really early.
Exactly.
I am not a morning person, so maybe I will just stay up late.
That's okay. There'll be 3 planets to see still.
Excellent. All right, so any interesting stars or constellations to take a look at? What's exciting during July?
I'd probably steer you towards the constellation called Boötes.
Boötes,
yeah. So it's...
How is that spelt?
Oh, it's Bootes, but you pronounce both O's, which it's an odd one to say, definitely.
Okay, so it's not booties.
Yeah. No, not booties, Boötes.
Boötes, right.
Yes, yeah. So Boötes is often called the herdsman. It's quite a good constellation to see up in the north this month. So the constellation kind of looks like a kite shape, but like a lot of constellations here in the south, it's upside down. So the base of the kite is our 4th brightest star in our night sky.
Okay. So I'm looking, is it like high up in the north or sort of lower down?
Lower down in the north, yeah.
Okay, so there's a really bright star, 4th brightest star in the sky.
Yeah.
Does it have a name?
It's Arcturus.
Arcturus.
Yeah.
Oh, I've heard of Arcturus.
Yeah.
Okay.
Yeah.
So we look for that, and then you said it's like a kite shape.
Yeah, it's kind of a kite type shape, but it is upside down. So it's almost like a little diamond, and then you've got kind of 2 things coming off.
Okay, like little spin-off things.
Yeah.
All right. And is it like small or quite large, this kite?
It's quite large in the night sky. So a similar sort of size to what maybe Orion would be like in the sky. So it's dominating quite a big portion of the sky.
So it's pretty hard to miss.
Yeah. Definitely worth keeping an eye out for.
That's good to know. And you said it was a herdsman.
Yeah. So there's a lot of stories and a lot of myths around Boötes. So there's lots of different stories. So often it's depicted as a herdsman of oxen or a farmer, but it's basically a person is what people are seeing instead of in the kite shape.
I see. But you said because it's upside down, then I guess if you were trying to imagine a person there, the kite would be the person's sort of torso.
Yes. Yeah. Absolutely.
Fantastic. All right, I know what I'm looking for now. Is there any other exciting space news? What happened in July? What's happening?
Yeah, so earlier on this month, Earth reached aphelion, on July 7th, which was last Friday. So this is the point where Earth is the furthest away from the sun. So Earth's orbit, the path that it takes around the sun, is not perfectly circular.
It's not a perfect circle, is it?
No, not a perfect circle at all. So we do have a far point and we do have a near point to the sun. So the furthest point we reached last Friday.
Oh, and that's aphelion.
Yes, yeah.
Okay. And I suppose a question that immediately comes to mind. So sometimes we're closer to the sun, sometimes we're further away from the sun over the course of the entire year.
Yeah.
Is this related to the fact that it's now the middle of winter? Is that why it's cold at the moment? We're further from the sun?
It is a logical train of thought to think that when the Earth is the furthest from the sun, this would be winter.
Yeah.
And when we're closer, this would be summer. But this kind of falls apart when we realise that at the moment it is summer in the northern hemisphere. So if that was right, it would be cold all the way around the planet. But we do have different seasons at different times.
Right, so it's not related to...
Yeah. So our seasons are more closely related to the tilt of the Earth's axis. So Earth's axis, the point that it turns around, it's not straight up and down. So it's slightly tilted by 23.5 degrees.
Right, I have heard that. And so at the moment, is the tilt facing us away from the sun, basically?
Yeah, so when the North Pole is tilted towards the sun, like it is now, the Northern Hemisphere is experiencing summer and we're experiencing winter down here in the Southern Hemisphere.
Right, and the fact that aphelion occurs in the middle of our winter is just an entire coincidence.
Yeah, purely coincidence, absolutely.
That's fantastic, but very misleading. If you don't think through it carefully, you could easily jump to the wrong conclusion.
Sure is, yeah.
As I'm sure many people might have accidentally done. Now, is there any other interesting things in July?
Yeah, July and winter in the Southern Hemisphere is a really, really great time to get a really great view of the Milky Way.
Okay.
Yeah.
So the Milky Way, as in is it more easily seen at different times of year?
So it moves across the sky and we can see the most detailed kind of image of it at the moment. So if you do step away from light pollution, if you manage to pop out into the country and take a look at the night sky, you can get a really beautiful view of the Milky Way in this season.
Okay, during winter. Gotcha.
Yeah.
But we need to get away from light pollution.
Yes, definitely.
Yeah, okay. So if you can get out of town, then take the opportunity to do so. I'm driving to Bustleton tonight.
So you might get to have a quick look.
Might have a look at that.
Yeah.
Okay, wow, this month is packed. Is
sure
there
is,
anything else?
Yeah.
Keep them coming.
So we do have a meteor shower this month called the Delta Aquarids. So it's coming from the direction of the Aquarius constellation.
Is that why it's called the Aquarids?
Absolutely, yes. Yeah, so this is the best time to see it just before sunrise, maybe in the last week of this month.
Oh, that's handy.
Yeah.
So in the constellation of Aquarius.
Yes.
Ish.
Yeah.
Yeah. And before sunrise, did you say?
Yes.
Yeah. Okay. I'll see if I can get up. I've already stated clearly I'm not a morning person.
Well, if you do wake up, you get to see 2 planets and maybe a meteor, so it's not bad.
Actually, that's not a bad motivation to get up, is it? Wow, it's a huge month. We've got planets, constellations, the entire Milky Way, the aphelion. Is there anything else anything else I can see in the sky?
Absolutely. Maybe one more thing. So the ISS, the International Space Station, should fly over Perth on the 17th of July at about 6:30 p.m. and then again on the 20th of July at about 10 to 6 in the morning.
Okay, that's good to know. And if I'm going outside to look for the ISS, what does it look like? What am I looking for?
Yeah, so you're looking for a big bright light in our night sky that's kind of moving steadily across the night sky, so it's worth having a look.
Oh, okay.
Yeah.
So it's not like flashing or zigzagging all over the place? Just
No. So a continuous straight line is what you're looking for.
Oh, okay. Yeah. That's pretty easy to keep an eye on, I think. Good to know. All right. Well, that's there's a lot to do outside in the night sky this month. So let's leave Earth behind. Any other news in the big wide world of space that's happening during July?
Yeah, absolutely. The Euclid Space Telescope launched on the 1st of July, which was pretty exciting.
The Euclid Space Telescope. What is the Euclid Space Telescope?
Yeah, so the Euclid Space Telescope, you can think of as kind of a mashup between the Hubble telescope, which created visible light images, and the James Webb Space Telescope, which looked at near and mid-infrared light or heat. Mm-hmm. So Euclid will do both.
A bit of both.
Yeah, so it's got a visible camera and then also a near-infrared camera, so it's going to do both.
Yep.
Yeah.
And what's it looking for? What's it going to do?
Yeah, so primarily it is a survey telescope. So rather than looking at specific things on demand, it's going to be looking at huge areas of the sky, so hopefully about a third of the sky. and it's going to look 10 billion years into the past, but it's mainly looking for galaxies. So it's hoping to discover and categorise 2 billion galaxies.
2 billion galaxies.
Absolutely, 2 billion galaxies.
My goodness.
Yes, so
it's like
a lot of data.
Creating a massive galactic data set,
Absolutely,
basically.
yeah.
That's astonishing. I still have trouble wrapping my head around, like when you look up in the sky, there's 100 billion stars, but that's just one galaxy.
Absolutely,
and you're saying Euclid
yeah.
is going to be looking for billions of galaxies.
Yes, yes, it's hard to wrap your head around, definitely.
So literally maybe 100 billion stars.
So many, yes. Yeah.
And that's just like a third of the sky.
Yeah.
This is, wow, that's fantastic. So Euclid is making this massive data set, this galactic map of 2 billion galaxies. Why is it doing that?
Yeah, so the Euclid Space Telescope aims to study how the universe has evolved. So the universe has changed over time, and we think dark matter and dark energy may be responsible, but we don't really know what these two things are.
Wow, that's just a small mission scope.
Yeah, just a tiny feat.
Okay.
Yeah.
Yeah, now I've heard, dark matter and dark energy have sort of entered the public discourse, and even though we don't really know what these are, can you still give us a quick summary of what these are? What is dark matter?
Very easy task, Leon. Thank
Yeah.
you. So dark matter, unlike normal matter, it doesn't absorb or reflect or emit light, so we can't really see it. So it's dark or invisible matter that we can't directly detect, but we can see the effects of dark matter. So galaxies behave as if they're heavier than they look, so they spin too fast, and they often group together into clusters that seem to be unable to hold themselves together. But we can't account for this gravity with the things that we can see, with the matter that we can see. So this mysterious extra gravity we kind of call dark matter as a bit of a placeholder.
Oh, right. Okay, that is actually a pretty succinct explanation. So they spin too fast. You mean so we know the galaxies spin. Is it a bit like if you drive around a roundabout too fast and you feel yourself getting flung outwards? Would galaxies, in theory, just fling themselves apart?
Absolutely, you got it. Yeah.
But the fact that they don't tells us that there's more stuff there than
exactly. There must be more matter somewhere.
Yep.
We just can't see it.
Right.
Yeah.
Okay. So we can look at a galaxy and estimate the number of stars and use that to estimate roughly how heavy it is, and that's just not heavy enough?
Yeah, so it's not heavy enough for the effects that we're seeing, so there must be some other factor in the middle somewhere.
Oh, right. Yeah, okay, I think that makes sense. And what about dark energy then?
So dark matter. It's like the merge of the two. Even more mysterious. So this is the tendency for the expansion of the universe to speed up. So we've all heard that our universe is expanding, but what we now know is the universe is expanding even faster today than it was in the past. So the expansion is accelerating. So it's expanding much faster today than it was a billion years ago. And this tendency for the universe to speed up as it expands, think of it as a result of dark energy, this invisible energy, this thing that we can't quite account for.
So it's sort of almost pushing things apart.
It is, yeah, absolutely.
Wow. And but we don't really know what it is or how it works.
No. So this is the hope of the Euclid telescope, is it might be able to
unravel some of these mysteries.
Yeah.
Okay. So it really seems like dark matter and dark energy are these placeholder names for things that we're still sort of poking at the edges of.
Exactly, yeah. So we know something's there, but we have no idea exactly what is there.
Right, and hence enter Euclid to try and discover. So you said it's going to look at how the universe has evolved over time, is that right?
Yes, yeah.
So how exactly is Euclid going to study the dark matter and dark energy then?
Yeah, so we can't see dark matter or dark energy, so it makes it really hard to study these things, but we can see the effects of it. So we can see galaxies.
Yep.
We also expect the behaviour of galaxies to change over time as the universe changes over time as well. So when you see a picture of a lot of galaxies, it's important to note two different things. So first is that the galaxies are all different distances away.
Yeah.
So some are further out than others and some are a little closer to us.
And that's easy to forget because they're just all on a single picture.
Absolutely, yeah. So it's hard to kind of understand the third dimension to them.
Yep.
So the other is that the further away something is in space, the further back in time we're looking.
Yes, I do recall that. And you said Euclid would be looking back up to maybe even 10 billion years.
Yeah. So that's kind of the hope and the aim. Yeah.
Yep. Okay, so when you look at a picture from Euclid, you might have a galaxy that's close by, maybe you're seeing it 100 million years ago, and just next to it in the picture, but in the third dimension back, it may be another galaxy that's 5 billion years or 10 billion years in the past.
Absolutely. So we'll see when the images do come back, but hopefully we will be able to see images exactly like that, where you've got different timestamps in the same picture.
Yep.
It'll be pretty cool to see.
Okay, so we're looking at galaxies at different eras of the universe. I feel like this is going somewhere.
Yeah, so what we can do is look at galaxies that are at different eras in the past, absolutely. So we can look at the shape of the galaxies and how they're grouping into clusters and how they are moving and interacting with each other. And since the behaviour of galaxies is affected by dark matter and dark energy, by looking at the galaxies at the different times in the past, we can study the effect of dark matter and dark energy has on the universe at different times.
Yep.
So if we add it all together, absolutely, yeah. So we add it all together and you get an understanding of how the universe has evolved under the influence of both dark matter and dark energy.
That's so clever. I see what you mean. Yeah, we can see the galaxies and what they're doing, and by working backwards, we can sort of infer what the dark matter and the dark energy are doing at different times as the universe has changed.
Absolutely, yeah.
I think that's the bit that matters. As the universe has evolved through time, we can then see the evolution of dark matter and dark energy. Mm-hmm. That's cool. Notice that at no stage through this are we going to see the dark matter or the dark energy.
No.
But we're going to see how it has changed and evolved over time.
Exactly, so we can better understand what we're looking at, definitely.
That is so cool. And so the first step is, I guess you need the data to gather data on millions of galaxies.
Yes, definitely.
So how long is that going to take?
Yeah, so Euclid launched last Friday, but it's still going to take about 3 months until it starts collecting data.
Okay.
And it will take about 6 years to collect all of the data. So that's going to be its full run is hopefully about 6 years.
Right. Is it going to just like stay up there for 6 years and collect it all and then send it all in, or is it like continuous?
Hopefully continuous, but it depends.
And how much data in total are we talking?
So we're talking about 30,000 terabytes of data.
30,000 terabytes
of data.
My goodness. Yeah. I mean, you can kind of expect those numbers if you're talking about 2 billion galaxies.
Yeah, and a third of the sky.
A third of the sky, and how much data you want to get from each galaxy.
Exactly.
It adds up very quick. 30,000 terabytes. That's staggering. So the name Euclid is ringing a bell. Where's the name from?
Absolutely. So the name Euclid comes from Euclid the mathematician, so sometimes known as the father of geometry. So all of the geometry that you studied in high school is actually Euclidean geometry.
That's where I've heard it.
So that might be why it kind of rings a little bell, but yeah.
Yeah, like so nice triangles and circles and that sort of stuff.
Absolutely, yeah. You got
okay. And so how is the name Euclid chosen? How is it relevant to the universe today?
So Einstein taught us that gravity is the curvature of space-time, so the deviations in straight lines and flat geometry. So dark matter and dark energy can affect the curvature of space-time, and Euclid will figure out and try and determine if our understanding of gravity is complete.
Wow. Okay, I did manage to keep up with that. That's very clever, isn't it? That the Euclid was known for straight lines and nice, simple geometry, and now the Euclid Space Telescope is probing the very, very limits of our understanding of geometry and the universe.
Absolutely, yeah. It's quite fitting, definitely.
What a way to go. So I guess failing that, we should go out and look at the curving Milky Way arching above our heads during the winter months.
Yeah.
I think that's a wonderful place to finish. Thank you so much for being here today, Sharna. What a fantastic conversation.
Well, thank you, Leon.
That's it for this episode of Particles Please Look Up. We'll see you next month where we talk about the night sky and the space news for August. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.